Okay, for people who are joining this live stream, we just finished another one. This is a different topic. This is language development, Wolfram language development. And it seems that this is column day. So we are talking about how to reference, access, and do things with columns in arrays.
Yes. So this is an important topic, and users have suggested multiple times the need for this and ways to approach this.
Right. So, I mean, we did years ago, we had this concept of bands, which has been only somewhat successful.
Exactly.
Yes,
That's the second point. Exactly. Yes. So the idea here, I think, is that alternative to having multiple column functions, we can have a more powerful symbolic position spec.
Yes. Which is what we've kind of already done with band.
Exactly. Band is a rather powerful construction because it doesn't have to be always kind of tilted. It can be horizontal, as the following examples show.
Yes, I understand. But it doesn't have to go all the way across either.
Exactly. Yep.
So one thing that we've never used is the word slice.
Right. Yes. At the very end of the notebook, there is a suggestion of an implementation.
Okay. Mm-hmm. Okay. Because I think column is kind of a shame that it is. I mean, maybe there's well, we've already used column for something else, but in addition, okay. Yes. Deeper objects on the right-hand side.
Right. So at the moment, only sparse array understands band. And so, of course, we have the many functions that take the position spec. And it would be great if they understood these or something similar. Because our two main structures are part and extract. So part is effectively one-dimensional. And the symbolic specifications for part are all unspan, which are great. We don't have a similar symbolic specification of large subsets of positions for extract.
Yeah, I understand. Multi-bands, okay.
Yeah, I was just trying to show the whole power of band, which is.
Yeah, right. Which has not been properly, moved across the system.
Exactly.
Okay. Now we've got the whole zoo of column functions.
Yes, we have discussed in other times having these functions. So what I did is just commenting on what they could do and potential problems they could have.
Yeah, so column, I mean, yes, you can either have column map as a map at or as a subset map.
Exactly. And it's interesting to see that the two main implementations are nearly identical. So column map is map at f x per all comma n, and subset map is f x per all comma n. Which shows how related both map at and subset map are.
Yeah, except they do different things.
They do different things, exactly, but they follow the same notation for doing similar things.
Right. Now, we thought that this notation, all comma n, which is a pretty civilized notation for a column, would work. But yet people still want column, because that is a perfectly reasonable column thing to do. I mean, we can say something like, we can make a, some random integer thing of, and we can perfectly well say %, all comma 3, and we will get that column.
Right.
Now, if we want to operate on that column, so one of the issues is we don't have a good way to say we don't have a great way to say just map something. I mean, if I want to make this, for some reason, one wants to do the row mapping. So one possibility is we take this and we want to return something like this. Okay. Whatever that means. That's like a subset map onto that set of things.
Mm-hmm.
In fact, I would think.
So that's a row. So that would be mapat 2.
Fine. Well, and so I don't understand why I can't do. So what you're saying is, if I say map at f blah blah blah, I see. The problem here is, no. I mean, what's wrong with this?
No, that's fine. That's the first column map as a form of mapat.
Yeah.
And we
Now, for some reason, one doesn't think of doing this, but it's certainly easy to do.
Right.
Okay, so you're saying the other case of this, which won't, I don't know what this will do actually. I mean, if I say subset map of this.
In this case, nothing. It really wants to check in advance that it returns a list.
Yeah.
So that will give an error.
Which is the right thing.
Yeah. I mean, if you try now accumulate, for example, that gives a list from a list, then it will work.
Or reverse or something.
Yeah, exactly.
Yeah, or actually, better version of that would be sort. So that's perfectly civilized functionality.
Mm-hmm.
By the way, we should give some examples of SubsetMap doing this in its documentation.
Yeah, but probably there is already, but yeah, I will check.
Do we have a good place to put, column functions? Oh my gosh, we've already had discussion of column functions. How long ago was our discussion of column functions? I don't even want to look. Okay. So let's keep going down here. Linear combination of columns. Oh my gosh, how do you do that?
Exactly. We don't have a good notation for that.
And or the operations of, Gaussian elimination or something.
Right. So not even the current subset map can do that, because you need to look at several columns at the same time.
Right.
And so this would require a generalization of subset map. Query can do that, but that's highly non-trivial.
What does query do on an array?
Effectively, as if it was acting on the data set of that array.
I think we should look at the query more seriously, because I don't think it's been properly worked through.
Yeah, I agree.
Okay.
Yeah, so this is yet extensions of so here I'm trying to create a slice, which would be this symbolic specification of position specs with two particular cases, which I'm calling lowercase row and lowercase column, just for example.
Okay, but in reality, this, so let's take, where's your matrix defined? Matrix is here. Mm-hmm. Okay. So this is equivalent, if I'm not mistaken, to extract a matrix all, 3.
Yeah, exactly. It's just a simpler notation.
Well, almost anything we put in there is going to be longer than all, 3.
Yes, that's true.
unless we had a notation, I mean, unless we had a special character type notation for the thing, like a prefix form.
Mhm.
So, I mean, that's one possibility, that what would happen. Okay, imagine there was a thing called column slice or something.
Mhm.
Or even, I mean, imagine we had a prefix form, okay? Boy, what would it be? I don't know, let's say it was, I'm trying to think of something that isn't ambiguous here. Okay, semicolon, colon. Okay,
Mhm.
it's a little bit obscure, but let's say it was that. Semicolon, colon, 4. Okay, and that means, so that's then equivalent to a slice of, let's say, well, actually, there might be an easier way to do this. I mean, so I don't understand why slice, because what we could also do is to say that slice of 4 by default defaults to a column slice. That's equivalent to slice all, comma 4. See what I'm saying?
Yeah. Yeah. It's a bit like what we do with carry, that by default is carrying the second argument, not the first.
Yes, because it's kind of pointless on the first. So let's just understand, if we had that kind of notation, so we could define this here. I don't know what does your slice here do?
It's a more complicated construction that is able to move with these rules. But so perhaps the definition you want is the row and col.
Yeah, okay. So let's call it lowercase slice.
Mhm.
I mean, I don't know where is that? I see. What does that mean? What is the definition of your slice here?
Let's see if I remember what the rule notation was.
I think that's just a sparse array version of, that's just the equivalent, I would think, of saying all, comma, ns.
Yes, exactly. It's subtracting elements from the second column. Yeah.
So I mean, in this situation, what we're doing is slice of level,
Mm-hmm.
arrow, index, right?
Yeah.
Alternatively, one could imagine a slice of index 1, index 2, blah, 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 right? Which is very much equivalent to the standard part spec.
Exactly, yeah.
So this is equivalent to a part spec that is the kind of a one-hot part spec where only the level, so that's equivalent to a part spec, which is sparse array of level, arrow, index, and whatever the depth is.
Mm-hmm.
Well, and the default is all.
Yes, exactly. Yes, there have been some comments that sometimes in deep data sets you have to write many alls. So that was trying to avoid that.
Okay. Okay, so this is again equivalent to all, 2.
Yeah.
What is this? So that says at level 3, you have elements 2 and 3.
Yes.
And at level 2, you have element 1.
Right.
And do we have a notation for that in extract? We do. that would just be an extract of all, comma, 1, comma, 2, 3, wouldn't it?
Yes, in extract, if you have two list levels, then you get the part, the tensor product of that.
So all, comma, this, right? Has another level of base bracket. No, what is that? That's something different. Same elements, but are not flattened.
Right. Well, yeah.
What? Okay, so let's loop back to what we were originally talking about here, which is the question of what column operations you want to do. So this column map thing says apply this operation. So I mean, right now we already have map at of, and let me define some array here. Let's do this. So I have that definition. Okay, so map at of f, comma, matrix, comma, all, comma, 2 will map that onto column 2.
Mm-hmm.
Okay. Now, I mean, the trouble is, what's happening here I mean, really, this isn't very hard to do. Map at all, comma, 2. It's just a little bit obscure to read. And arguably, you know, that should turn into, I mean, we should just have a utility function for some of these that just say column map, because you know, the difficulty of this is not that it's a lot to type. It isn't. It's that people don't conceptually understand what's going on.
I see.
I mean, there's really no typing problem here.
Okay. So my general suggestion here is that rather than having multiple column functions, if we had a powerful language for symbolic position specs.
Well, how does column insert work right now? Does insert work reasonably in that? I don't even know. I don't think it does. I think insert is a very simple function.
Right. Insert and delete, unfortunately, do not work well with the all, comma, 2. So I think I have an example in the delete section. A problem with insert is that it's going to insert always the same element. We cannot insert different elements. So that's why this little prototype uses transposing instead.
Well, but what would happen if we supported in, insert, and all for one of the IJK? So in other words, if we say insert into matrix list AB all, comma, 2.
Well, the problem here is that this is naturally equivalent to 1, 2, 2, 2, 3, 2, and then inserting AB in all those places.
Sorry, say that again. I mean, that's equivalent. What?
So change all, comma, 2 to the list 1, 2, 2, 2, 3, 2. So 3 positions, because that's right, three sublists, exactly. And yeah.
And this should be that.
Evaluate that. You see, it's inserting the list, because that's how insert is defined. That even if you specify multiple positions, it will insert the same thing.
Well, it's really what it needs is a subset insert. This is the same issue, sort of, as the map issue. The difference between map at and subset map. Isn't it? Is it?
Yes, a bit. So this is one of these cases in which if we had rules, we could say 1,2 goes to A, 2,2 goes to B.
Okay, so in other words, if we have an insert like we do with the replace part,
Exactly.
if we say insert, and then we could say something like all comma 2 goes to ABC.
Right.
Potentially. That's interesting.
Recall that I think that in before version 5, replace part also had this multi-argument form without rules, and then it was changed to the rule version.
Oh yeah, absolutely. That's right.
But insert was not changed in the same way.
That's correct. We didn't think of that. But it's a good idea. It's a really good idea. What would happen? Okay, so that's the story for insert. What about delete?
Delete could support the all comma 2, but doesn't.
Okay.
Because it can be expanded. So for example, in the same example you have, if you evaluate this, it will complain. But if you change it by the list 1,2, 2,2, 3,2, then
fine. So it could work.
Yep.
I think this is really interesting. I think this is a really good idea, which I'd never thought of before. It's unbelievable. In 30 years, we never thought of that. But anyway, it's big space.
So there are a few places in which we support the position spec function, and the all comma 2 notation is supported in some of them. So something we could start with is supporting systematically all comma 2.
Yeah, I agree. I mean, in insert, this is particularly interesting. Okay, so,
Yeah.
I'm trying to think. I mean, the only problem with map out of all comma 2, the good news about this is it's very clear the F is going to be applied to each element.
Mm-hmm.
Yeah. Now subset map is a little bit of a weird name for, well, it's not that weird, actually.
No, I think it's good that it's a map. It belongs to a map function family.
No, I agree. That's magnificent. That's quite magnificent.
Yeah, because the third argument of SubsetMap takes general position specs. We could have a list of individual positions.
Yeah, no, I understand. Or it could be a band.
Well, band is so far, I mean, it could be supported. So far, it's only supported by sparse array.
Yeah, I get it. But I mean, band could be, okay. Carl is asking about inserting a column that is, for example, a sum of of two other columns. That's a good question.
Yeah, this is what we were discussing below with the code language.
Well, I mean, the way that we would have to do it is it would end up looking like, but that would be sort of a generalization of subset map. I mean, the one way to do it is obviously insert matrix, all comma 2 arrow matrix all comma 3 plus matrix all comma 4. Okay, this is some kind of generalized subset map. We could imagine a rule third argument for subset map. Or do we not even need that? Okay, so much like these other things, we could imagine somehow combining those with rules, I think.
Yeah, I'm not sure whether it's in the first argument or the third.
First, you mean second argument?
No, I'm thinking about the first, in the sense of a function that does something and another function that, I'm trying to think. Because the addition is going to be performed by the first function, by the first argument.
Sandra on our live stream is pointing out the analogy with take list. Don't quite get that, but that's some. Yeah, Carl is pointing out that he takes some that's a thing Carl says he uses for combining lat long coordinates into position. What does that do? What does the hash pos arrow do? I don't entirely get that.
I don't know.
Inserting multiple different elements, Sander points out, could be called and could be insert list. As take list is successively taking. Okay, that's interesting, but I think that the problem is, right, so we have in general, you're picking up n things and you're putting n things in. Oh, I see. The problem is, doesn't insert already take multiple, allow you to do multiple insertion? I thought it did.
Yes, but of the same element. So compare this notation with replace part, which has a similar situation. There's a notation in which you can insert the same, replace the same element.
Yeah, Carl, okay, this makes more sense to me. Okay, go ahead. Sorry, you're saying.
Yes, I was suggesting to compare the page of insert with the page of replace part.
Okay.
So here we have a way of
actually, hold the fort for just a minute. I have to be right back. Okay, go ahead.
Yes. So
Sorry.
in the fourth and fifth lines of replace part, we see the two cases. So the fifth one is replace many parts with the same element. And the previous one is replace each part with a different element.
Mm-hmm.
So I think that flexibility is what we are missing in insert.
Okay, so let's take a look at that. So this is saying, right, in insert, we don't have any rule syntax.
Right. And we have to replace all those positions by the same element. We insert the same element at those positions.
Right, so, okay, so let's say we have same element insertion would be insert into our matrix all comma 2 arrow x, for instance, right?
Yep.
Now, what we want, which we don't have a convenient way to do. No, actually, what does this mean? Does this mean, see, that's two things we could have here. We could have this, or we could have some list like that. Making sense?
Yep. That will become then ambiguous because we don't know whether we want to put that list at all positions.
Well, how does it work in replace part?
Well, we have to thread. In replace part, there is no all comma 2 notation. So that's a difference with band. In band, it does understand that if you place a list on the right, then that means a list and not a single element. Actually, it even works with matrices.
That it inserts them element by element, so to speak.
Exactly, like a submatrix.
Okay. So you're saying with replace part, there's no way to have kind of parameterized replacement.
Exactly.
I mean, the only parameterized thing we have is like map index, which is very low level parameterization.
Mm-hmm.
Because the typical thing you want, okay, is replace a column, for example.
Mm-hmm.
Okay, so how do you replace a column?
You would have to say, if it is the second column, you would have to say 1, 2 goes to A, 2, 2 goes to B.
All right, so that is again an example of a bad story.
Mm-hmm.
So the main problem is that in this, there's no auto threading.
Right. Because the natural thing is to expand all comma 2 in the same place where it is to the list 1, 2, 2, 2, 3, 2. And then all those elements will be replaced by the same new.
Mm-hmm. So, I mean, you know, I hate to point this out, but if we had something, this might be very, very obscure. If we had something more like that, no, not flatten out. What am I talking about? What is the thing that we're with the auto flattener?
Flattened in. But I'm not sure this would work because it's going to start by putting each of these flattened in elements at each place, and then they will flatten.
Yeah, I don't think it's quite right. But what I'm saying is some right-hand side.
I see, that forces to be treated like.
something that forces auto distribution, because that would be the same thing, you know, here. Okay, in this case, that will just generate an error, won't it? Because it'll be the wrong shape.
No, that could be interpreted as if you change the all, 2 by the list above, 1, 2, 2, 3, 2, that will work. Oh, well, sorry.
Actually, I see. Insert the same element at every position.
Exactly. So far, everywhere where we admit all, 2, it's fully equivalent to replacing all, 2 by that list.
Okay. What we want here, we need this to splice.
The only precedent we have is that band does that because it's band.
Because what?
Because it's band. We know that band takes whatever is on the right and threads.
All right, so what would this look like with band?
We would have to give the first element, the last element, and the step. So it would be like 1, 2, 3, 2, 1, 0.
That is so freaking grotesque.
Yeah. So that's the first element, the last element, and the.
But there might be an elided syntax for band.
Sorry, I think it's 0, 1. It means move.
Yeah, right.
Yes.
Okay, so let's look at, so that is sort of an existence proof that we can represent. Okay, here's a crazy idea. What if instead of all, we were to say automatic, 2? Or some other word that means, and it's not a completely stupid word because that's basically saying, okay, let's look at that communication replace part, okay? Okay, so there's a problem. All right, so we go automatic XYZ. Okay, now, then here's the problem. I mean, if we said automatic, well, it's not clear that that does the wrong thing. I mean, because we just have a matrix there.
Yes, we need a matrix on there.
Right.
It could be a bit complicated if we mix them, like automatic, all. But
why is that so complicated? That means, okay, so what would that mean? That would mean, oops, what the heck did I just do there? Help. Automatic, all. Yeah, there's no problem with that. What that would do is you'd say X, Y, and that would take the X for the first column, the Y for the second column.
I see, and repeat them. I see.
Repeat them. This is interesting. Let's look at some other cases. Okay. Well, what else do we need to? Okay, so let's look at delete. I don't think delete is problematic. I think delete is quite easy.
Yes, I think so, because, well, the only thing I was that might be problematic with delete is that if we say, for example, delete all the elements of the second row, do we leave there an empty row or not? I mean, deleting all the elements of a row, is it equivalent to deleting the row or to leaving that row empty?
No, it's equivalent to deleting the row. We have no representation of an empty row. I mean, isn't that right? Well, we could just see that right now. I mean, if we delete, if we have A, B, C, D.
Mm-hmm.
Well, actually, let's do this. A, B, C. Okay.
Mm-hmm.
Now we say delete element 2, 1. Right?
Yep.
Oh, I see.
So of course, we could say here delete element 2, and that deletes the whole row. But when we go to all, I'm not sure which one is. Because the standard thing with all is the list of all elements.
Well, then we got the same deal with automatic versus all.
I see. Okay, I see the idea. I'm not thrilled with the word automatic, but I see the idea.
I don't think automatic is so bad. I think it just means it's an automatic index.
But it doesn't give this meaning of completeness of the whole thing. It's kind of...
Not the whole thing. It's threading over the whole thing.
Mm-hmm.
Yeah, Carl is suggesting full as an alternative to... I agree. Full is something we could consider.
Mm-hmm.
Right. Look, I think the concept of a symbolic part specification I mean, I'm wondering whether automatic in this sense has a meaning inside extract.
I don't think so, because there is no notion of threading to something else there.
Yeah, so it's equivalent to all.
Yeah.
In extract, okay.
I mean, the idea of supporting band is still interesting, because sometimes we want to do things on the diagonal, for example.
Oh, sure. I mean, supporting band is fine. It's a bunch of work. I think this is more valuable. This rectilinear stuff is more valuable.
Mm-hmm.
But, okay. Okay, so let's look at what other things. So the linear combinations of columns business. Okay, so I claim let's see what that would look like. What would that look like? That would be something like this. Automatic to arrow, matrix, all comma 2 plus matrix all comma 3. That's what that would be. Now, is there alternatively a subset map generalization way of doing that? I bet there is, because I think what it is there, if we allow automatic in subset map, I reckon we can do this. Okay. Maybe. I don't completely see how to do this.
Well, it would have to be a list of lists in the last argument. So somehow in SubsetMap, we pass to the function in the first argument a list of elements. So what we need now is to pass two lists of elements.
Right.
So that we add them and it still returns a single list of elements.
Right.
So it feels as if the third.
So it'd be something like this. It would be this, and then it would be all comma 3. Well, I'm just making up what these are, but all comma 5 or something.
Right. So it would be matrix in the second argument, and then we would need perhaps a rule. All 3, all 5 goes to all 2. So the idea would be what we take and where we put it, which so far is the same thing.
I see. We're putting it in the same place.
Right.
Okay. So this will be the where it gets put.
Right.
Okay. So the minimal case of this would be, I mean, right now, we've got subset map of accumulate ABCD 2, 3. Say 2, 3, 4. Okay. Actually, let's say okay. But this could be something like that.
Right.
Which would mean overwrite the elements at positions 1, 4, 2 with the results of applying that thing to 4, 4, 2, 3.
Right.
Okay. So then the multi-form of that is not too difficult to understand, I think. I mean, the multi-form, which are now we would have to decide, and probably it's more convenient to have the first argument be, I mean, we might have to say, to get it, the question is it passed as a list or not? Whether we have to say apply plus onto these things.
Right.
Which perhaps for consistency we would have to do. So then this would become, there's some matrix here. And then this would be the list, let's say 2 all, comma 3 all.
Do you mean all 2? Or do you want to do it with rows?
No, I meant all 2. Yeah. Arrow. And then that goes, actually, I really want, I think that has to go to automatic 4, for example. Is that right?
I think in SubsetMap we would understand all effectively as automatic.
Yeah, probably so. Yeah, Carl was asking, what about subset apply? We might get there. Depends how common this all is.
In this case, we could do total, but that's specific.
Yeah. No, we couldn't do total. Could we do total? Because that will be passed. Oh, yeah, that's right. Yeah, that's right.
Because by default, it does one level only.
Yeah, right. Okay.
Now, these we can replace a column. We cannot insert a column.
Well, but if you want to insert a column, you use insert. Right? If you want to get rid of 3 columns and add, I mean, then you'd have to have a mixture of inserts and deletes, I think.
Yes, but that's outside SubsetMap.
Right.
That's fine.
Well, you're saying could SubsetMap? I don't think that's a reasonable thing to do because.
No, I'm saying that this solves part of the problem, which is the do something and replace a column.
Yes, if you just want to do something, use map at. I mean, I think, wait a minute, if you just want to do something to a column, but it depends whether you want to do it element-wise to a column. If you want to do it to the whole column, you use SubsetMap. If you want to insert something, you use insert. Now, I mean, the question is, can we get a simpler syntax for band that does the useful thing? Like, for example, just band of an integer might mean a column, because band of a single integer doesn't mean anything right now. Okay, so this is now a discussion of band.
Perhaps some strings.
Yeah, it's possible too. But could band of n mean column n? Doesn't seem obviously stupid to say that.
Well, the problem I see is that the first definition of band is a diagonal band. So it would be a bit strange if we now change that to be vertical for a single.
It's not vertical. I mean, the first definition of band there is a list.
Yes, but it's a diagonal list. It represents.
Well, I understand. It starts with 0, 0, for example. No, 1, 1.
Yeah.
And then goes diagonally.
Exactly. Same thing if you have 1, 1, 1 for something of depth 3.
Sure. Now, the question is whether band of 1 or band of 2 could be equivalent to band of, this would be 1, 2, minus 1, 2, 0, 1. I don't know. It doesn't, I mean, it's a little weird, but I don't think it's particularly weird because the other case isn't very useful. I mean, band of 1 isn't very useful here.
Yes, but it's a bit strange if band of 2 is different from band of 1, 2, because they are starting at the same place. So band 2, column, I think would be easier to read.
Ugh.
And it would be equivalent to band 1, 2, column.
Carl is saying he finds it crazy that band is diagonal. Yeah. Band was a function introduced. I mean, it's to do with, it's like finding tridiagonal matrices and things. Do we have a thing? Oops, yeah.
What about having a column band too, and a row band? And then this can have other arguments, like a step.
It's possible. The reason column livestream is suggesting column of 3. Sadly, we've already used column. For a not totally stupid thing.
Yeah, and then we have a row as well.
Of course.
So it's they form a pair.
What's that?
They form a pair. I mean.
Yeah, right.
They go together.
Well, look, the question of whether we have yeah, I'm trying to think, is there another thing other than band that we could use here? Column parts or something. I don't like it very much.
Slice, we said before.
Yeah, either slice or column slice. I still support the idea of slice defaulting to a column. Because then it can easily be generalized. What's that?
With slice, I would find it more acceptable than with band. Band has such a strong diagonal precedent.
Oh, I understand. So, I mean, band is diagonal, slice is rectilinear, so to speak.
Yep.
So then, slice of n would typically be equivalent to something like n automatic comma n. Right?
Mm-hmm.
There's a long comment from Sander here. Let's see. A mixture of insert and map apply would be interesting. So you want to add a column to a matrix that is the sum of 2 other columns. Yeah, I mean, the question is whether insert, I mean, what you're talking about there is some kind of map insert type thing, or insert map. Where basically what's happening is, well, no, I think you're right, insert apply might be the correct form. So then we have a matrix. Oh boy, what does this do? So, wait a minute. No, actually, this is, oh boy, I'm getting my brain tangled here. What this is doing, okay, so insert apply. So the general case is take various quote slices, apply an operation to them,
and insert the result.
yeah, and insert the result somewhere. Okay, so whereas insert would require you to, so the question is, it's an insert. What is it? Is it a map insert? No, what it is it's something like map at insert. Is that right? Where it says, okay, so the first thing is an F, a matrix, and then where from and where to, I think.
So this is very similar then to the SubsetMap extension we were thinking about, in which the last two arguments are connected by a rule.
Yes, the only difference here is that this is an insert version of SubsetMap.
Exactly, insert instead of a replace.
Right. Well, I mean, we could imagine a subset map insert. That might be the better name for it, because it is exactly doing a subset map.
Right.
Although, to be fair, the insertion doesn't have to necessarily be conforming, whereas a subset map, it does have to be conforming.
What do you mean?
Well, the insert, no, I'm wrong. If it's not at the top level, a row, right, we could just insert X as the fifth row.
Right. But if it's a column, it has to conform.
Right. Okay, so subset map insert. So let's just take a look at what this would look like in a real case, okay? So subset map insert, let's say we're going to put the total of two rows, matrix here, and then it would say, no, this isn't quite right. This isn't quite right. I mean, we could say slice 2.
Well, the previous notation we were using was all comma 2, all comma 3, a row, all comma 2. That means insert at the second position.
I see what you're saying. So this would just be, okay, slice 2, comma, slice 3. Gosh, I can't type this word. Arrow, slice 5. And the only difference is that really the other one is short for subset map replace,
right,
which is really the same, which is subset map itself, because map is by default a replacer. Why isn't this called subset insert? No, because it has a map operation in it.
This is a similar discussion we had with SubsetMap, in which we were discussing whether it's more a map function or a replace function.
Yes.
It's both in a sense.
But I think this is an interesting function, subset map insert. But then, okay, so then this map corresponds to insert So a pure insert. Let's look at insert for a second. Okay, so insert in a matrix, slice 2, arrow, ABC. That is equivalent to insert of automatic, comma 2, ABC. Correct?
Yep. I mean, it doesn't work right now, but it could work.
Yeah. Okay. And delete matrix, comma slice 3. It's pretty clean. I mean, that's pretty clear. I mean, that's pretty reasonable, which is the equivalent of delete matrix of automatic, comma 3, or full, comma 3.
Mm-hmm.
Or
in this case, all also would work.
no, it wouldn't.
For
No, it wouldn't. Oh, wait a minute. Would it work? But the row case wouldn't work.
Exactly. The row case wouldn't work, but the column, we have no alternative.
Okay. Fair enough. This would work with all as well, but a row would with all would end up with a null list.
Right.
Okay, what other functions are there in our collection of columnable functions? Well, so column part, the obvious thing to do would be matrix of slice 2. Right, giving the column.
I don't like very much this, because in part notation, the first thing you provide is always about the rows. So we would be breaking, this could have consequences.
Okay, so that's a question mark. I mean, do we agree that extract?
With extract, there is no problem, yes. Because what we are discussing here are position specs, not part specs.
Okay.
So the functions that take position specs are the ones we discussed: delete, insert, replace part, extract, and SubsetMap.
Is that all? Really?
So.
I find that hard to believe.
Yeah, we don't have so many with position specs. So
there aren't things. Well, what about things like? Well, what about map ads?
Yes, sorry, I forgot that one.
So that we should expect to work.
Yes.
Well, we've been reserving slice all these years, so maybe we finally get to use it. Are you sure things like, I mean, there's a lot of things that have level specs.
But that's different. No, the other one, I'm seeing now flattenat as well. But we'll have more add functions.
Okay.
So again, it's insert, delete, flattenat, map add, replace.
Wait. What would flattenat do?
It would flatten, you specify a position at which effectively flatten is being mapped at.
I think that's pretty funky. I mean, flattening is structure modifying. I don't really believe in that one.
Well, it will do perhaps a weird thing, but the point is that the second argument of flatten out is a position spike. It takes a list of positions.
But tons of things take lists of positions, don't they?
No. That's what I'm saying. Not so many. Again, I may be missing some, but very few. We have gone through this a few times.
Okay. So Sandra is asking about this. Partition that. Takes me a moment to read this.
This would insert.
Yeah, it inserts the. Yeah, that's right. It inserts the total of every row.
At the end, right.
Well, it's not the total of every. It's the total of the elements 2 and 3 of every row.
Yes, exactly. Mm-hmm.
Isn't slice of 2 sequence all, 2, says Sander. It's not sequence. It's in most places it will be a list, automatic, 2.
I think he's talking about the part specs. The problem is that, of course, we are converting one element into a sequence of 2, and that's going to confuse all part specs.
Yeah, I understand. Okay, listen, we should probably wrap up.
There are a few good ideas here for me to look at.
There's some very good ideas here. I'm very pleased with this. Very, very pleased. I mean, this has been this is a chestnut that's been, hardening in the sun for years. I think this is great. I think we are actually on track to solve this finally.
Mm-hmm.
Okay, we got to. Let's do. We're on we're not going to do it today, but we're on a roll. Let's go solve some other old chestnuts. I've got a list of old chestnuts. I think we're going to do exceptions soon too, and package layout, which is actually on its way to getting solved. But this column thing. So let's work through this. But I'm really pretty excited about this. This looks really promising to me. I think we should work through the automatic, whatever, and equivalently the slice, whatever. I mean, we haven't talked about what a multi-argument slice does, and we've got a lot of freedom in what that does. For example, I think your idea of the d-dimensional slice, level arrow index is perfectly good, and that would mean the hyperplane, hyperplane in the array, correct?
Yes, potentially the index would even take a sub-hyperplane if we have a span or whatever.
I see what you're saying. So in other words, I could also say, so what would it mean if I did slice 3, 5?
That's effectively like a part spec at the first level. But
okay, so in other words, what that means is if I were to do this, okay, let's do the following. Let's say I said delete in a matrix slice 3, 5. That would delete. So for example, this actually is a useful thing, right? I mean, I could say delete up to.
Well, if we are saying that slice with one argument means columns, then this would
delete columns 3 through 5.
Right.
Seems quite useful to me.
Right. So this will be equivalent to 2 arrow 3, 6, which is the default. So the default is the second level. Exactly.
That's equivalent to slice of 2 arrow this. Right, I agree. By the way, what would this do with associations? Or a data set, for example. I mean, we should be able to say data set. We should be able to do something like this. Delete data set matrix Oops. Okay, for example, slice header. And that should delete the column. If this is a list of associations, that should delete the elements of each association with that header.
Well, but then we would be working at the first level.
No, we're not.
Oh, yes, I see. It's a matrix. It's a list of associations. I see.
Exactly.
Yeah. Okay.
Right. Which is the typical data set where that is a column header.
Mm-hmm.
This is really great. This is going to really work well. We should have solved this years ago. It's a pretty simple solution, actually. I mean, and then if you want to get, okay, so Carl is saying, no, Sandra is saying hyperplane or hypervolume. What do we mean actually by that? So, no, he's right. What it means is we're constraining the index for level n, right? But we are constraining no other indices.
Yes, it depends. I mean, in relativity, we speak still of hyperplanes, even if they have multi-dimensions.
Yes, right. Okay, but so in this case, just for 1 second, the multi-argument slice would potentially be, so let's take the example of a data set where I think that's a more realistic thing. So let's imagine the planets data set, for example. Mm-hmm. Then let's say we want to delete
So I think here the thing to decide is whether if we have two headers, we mean act on the initial data set, or the second one will act on the result of having sliced.
Yeah, I think we have to. There's something to understand here also with respect to how dataset itself works, and how, because within dataset, we might have a dataset, and we should obviously be able to say slice header, and that should be equivalent to dataset of all comma header, right?
Yeah, slice itself could actually be an operator.
Be what?
An operator.
Oh, I see what you're saying. Where we say slice of 2 of the matrix as a curry-like thing. Exactly. Is extract matrix slice 2. Mm-hmm. Yeah, that's nice. Sandra is commenting that the term slice is already used in the context of image 3D slices, where it always extracts planes, 2D planes, not hypervolumes. I'm not visualizing this very well. I mean, when we say, what would it mean to have, if we only give one index, if we say level arrow index, I don't understand how we could ever extract anything other than what Sandra is calling a hypervolume. Because we're not constraining the other indices.
Right. To me, this is like codimension 1.
Yes. Yes, this object, the object defined by a single slice specification. I mean, for example, if we slice lev 1 arrow end 1, lev 2 arrow end 2, that could potentially be a codimension 2 object.
Exactly. I'm not even sure we need the list inside.
I think we do if we want to think about currying. I mean, I don't know how much currying.
I see.
I'm now confused by something. Does pot curry? Doesn't. No, it doesn't curry.
Right.
But extract does curry, doesn't it?
Yes, it does.
Well, actually, that's a bad test. Okay. Good. There was one comment on the live stream I just want to comment on. I'm late for something else here, which was a thing about inserting comments, right? A suggestion from Nicola about insert comment of comment position. The reason we can't do that is because comment just doesn't appear in the expression. You'd have to insert the comment in an abstract syntax tree of the expression rather than the expression itself. Because by definition, if I say comment hello, if I say comment hello times, 2 plus 3, I just get 2 plus 3. And if I were to say comment there plus 3, oh, for goodness sake, I don't get a syntax error but if I said multiplied by 3, I'd get a syntax error. All right. For some reason, I'm less, I feel, yeah, right. This is actually very exciting. We've solved some problems here, I think, that have been around for decades. So that's exciting. For some reason, my day is such that I'm not expressing exuberance as much as I might. But this is really good. And thank you, everybody here and people on the live stream. Very helpful. And Jose, I think we should just, we should pursue this, try and sort it out.
Yeah. I will analyze these ideas, but yeah, they look great.
Right. Sounds good. Okay. See you all soon.
Bye.
Bye.